Hello everyone, welcome back to the TechCloud channel. In today's video, we are going to discuss about TCP flags. So TCP flags is one of the important segment in the TCP header. So in this video, we will learn what are the TCP flags, what is the use of TCP flags, and the most important types of TCP flags. Let's first see what is the TCP flags. TCP flags are some various type of flags bits present in the TCP header segment. Each flag has its own importance. Also, flag segment is for 9 bits and each flag is 1 bit. Means the flag segment is for 9 bit total and each flag is for 1 bit. They consider for 1 bit as size. Now let's see what is the use of TCP flags. So TCP flags are used to notify a particular state during a TCP communication. It can also be used for the troubleshooting purpose. So this is basically let you know about the condition of the TCP traffic. If anyone asks to you what is the use of TCP flags, you can simply say that this flag is used to notify about the condition of the TCP traffic. The use of TCP flags is to let you know about the state of communication. Okay, now let's see the types of TCP flags. So the types of TCP, there are 9 types of TCP flags. 9 types of TCP flags. 6 flags we commonly use and 3 flags for special case. Let's first see these 6 flags. These are the only flags we commonly know and we commonly use in our daily network life. So the first in the 6 flag is SYN flag. Second, ACK acknowledgement flag. Third, RST reset. Fourth, finish. Fifth, push, and sixth is urgent, URG urgent flag. So if we see the basic of these flags, so SYN and ACK flag is used to initiate a connection. These are the only flag which we use to initiate connection. And then reset and fin flag, so these flags are used for aborting a connection. You can simply say reset and fin flag is used for abort connection, and push and urgent flag is used for data transfer. These are the high level definition for these flags. Other 3 additional flags which are, let's call it number 7, that is CWR, number 8 ECE, and number 9 NS. So about these 3 flags we will discuss later in the detail. Now let's start and discuss each flag one by one. So our first flag, that is the SYN flag. So SYN flag is the first flag that every host on the network use to initiate a connection. This flag is used by each host on the network to initiate the connections. So this will be like this. There is a one PC and the second PC. So whenever they start communicating to each other, they will first share the SYN packet or SYN flag to start the communication. So SYN flag is basically used to initiate connection by each host. The next one is acknowledgement. ACK is the short form. Acknowledgement flag. So acknowledgement flag, this flag indicate that the acknowledgement after the initial SYN packet sent by the host. Let's say here is a PC1 and PC2. So PC1 send a SYN packet to PC2. So the PC2 will reply, or you can say the acknowledgement will be performed on behalf of the SYN initiative. So this flag send after initial SYN packet. Initial SYN packet sent by host. Next one is reset. RST, reset flags. So reset flags, generally host send this flag if there is non-segment connection. So this flag has a special case. If there is a non-segment connection, then this reset flag will be sent by the host. Also, in case of no liable connection to answer at the remote host, means if this PC1 is requesting to some other PC, a remote PC we can say, and if this remote PC does not having the liable answer of the connection, in that case this remote PC will reply with reset flag. Or you can also say if they want to terminate the connection forcefully. If the PC1 and PC2 want to terminate the connection because of anything, so they can use reset flag. Reset flag to terminate the connection forcefully. The next one is finish flag. Finish flag is also similar to reset, but reset works for forcefully connection termination and fin works for gracefully termination of connection. What will happen here? PC1 will send something, so they will start SYN, then they will be SYNAC, let's say, then ACK, TCP connection created, then they done some data transfer, and at the end each of them will say each other for fin to finish the connection gracefully and finish acknowledge. So this is how they completely gracefully terminate the connection after data transmission. Once the data transmission is completed, they gracefully terminate the connection. So this is for use of fin flag. We can say simply gracefully terminate the connection. After this 4 flag, this 2 flag is very confusing. So in many interviews or in many ways we have seen the difference between urgent and push flag. They are same as per their behavior, but a very basic and very main difference that make them difference from each other. Let's learn about them as well. Let's discuss about them as well. Let me remove this. Okay, let me write like this. Urgent flag is here and push flag is here. Okay, so what happened for both of them? So this flag, urgent flag indicate that incoming packet as urgent, and this need to be sent to the remote host without waiting in the buffering and process immediately. What happened? Let me create. So let's call it, this one is the header. So what happened? There is a segment called urgent pointer in the TCP header, inside the TCP header. Whenever a packet sent from host A to host B, and if they want the packet to be immediately transferred to the host B, so they can use urgent flag. Telnet is an example, we can say, for the urgent flag. So what happened? For every connection, for every traffic, there is a buffer memory in the TCP. So the data we sent from source to the destination, the data is stored in the buffer memory of the TCP, and once the buffer is completed, then after the packet is sent to the destination. But in our case, in the urgent flag, the buffer memory will not wait to full the buffer memory. It will, as soon as receive the urgent flag data, and it will as soon as transfer the data to the destination. Okay, now the push flag. So urgent flag does not wait. Let me write. Urgent flag does not wait in queue. Immediately send to destination without delay in buffer of TCP. It does not hold in the buffer of the TCP. It just immediately send to the destination. Does not hold in the queue. Does not wait in the queue. Opposite of this urgent flag, push flag do the same thing, but let me create a diagram. Uh, layers, layer wise. 7, 6, 5, 4, 3, 2, 1. As we know, as per the OSI layer, 7th layer is application layer, then presentation, then session, and then transport. So here we have the TCP on the transport layer. So inside the TCP header, the buffer will be there, TCP buffer we can say. So our data just came from application layer. Our data came from application layer, hold in the buffer of the TCP. Once the buffer is completed, then the packet is sent to the, this one is sender, this one is receiver. So this one is also application layer of receiver, layer 7, layer 6, 5, 4, 3, 2 and 1. So what happened? Once the sender send the data from application layer, the data sent to the layer 4, and inside the TCP buffer the data is getting buffered and then after transferred to the receiver end. At the receiver end it will again store the data in the buffer of TCP header. Once the buffer is completed, then after the data is sent to the application layer of the receiver. So this is how the push works. So push need to wait in the queue. If there is a already ongoing process of data, so push will wait in the queue. Push wait in the queue, then also require the data store in TCP buffer. So the major difference between push and urgent is push does not wait in the queue and urgent does not wait in the queue and push wait in the queue. Push have to wait in the queue. For the example of urgent, we have seen TCP telnet, because whenever we put a command on the telnet, that command should be sent to the destination host as soon as possible. And FTP, we can say the example of push flag. So for the FTP, in FTP we send huge data, we send big data, small data, any kind of data. So the data insecurity should be confirmed, the data should be ensured to be reached to the destination. For that reason, every time we need to use push flag. Means for that, this kind of connection, this kind of communication, TCP use push flag because there no need to data loss. So this is the difference between push and urgent flag. Now let's discuss about the 3 more additional flags. These 3 flags are not so old, so they just came before 5-6 years ago. Before that we were using only 6 flag till the urgent and push. Let me remove this one. I hope you are able to understand the difference between push and urgent flag. Okay. The 7th flag, according to the new version, the 7th flag is ECE. ECE. If we generally discuss about these 3 flags, 7, 8 and 9, so these all flags are only made for congestion purpose. If there is a congestion in the network, then these flags comes under the picture of the traffic. So the first one is ECE flag. ECE flags called explicit congestion echo. Explicit congestion echo. This flag indicate that host is ECN capable. ECN means whenever this flag is on, so this indicate host is ECN enabled. enabled, or you can say capable. Once means the host is supportable for ECN, ECE. Capable. So ECN called as explicit congestion notification. Let me note it down. Explicit congestion notification. So these flags indicate that host is ECN capable during TCP handshake, and this notified by the ECN field in the IP header set to 11, means the ECN header bit will be set as 11. Whenever this is set as 11, in that case only it understand that it is a ECN field and it is a ECN capable. The next one is ECN nonce. ECN nonce. So this flag is used for concealment protection of ECE. Means if there is a congestion in the network and that need to be notified to the user or need to notify to the sender, so this ECN nonce flag is used to notify that there is a ECE congestion notification in the network. So this flag is used for concealment protection. The next one is number 9, CWR. CWR flag, and this is called congestion window reduced. Congestion window reduced. Again, the another congestion flag. So this flag used by the sender, this CWR flag used by the sender to notify the receiver that sender has received ECE flags. Means, let's say here we have this one is sender and this one is receiver. So this CWR flag notify the receiver that sender has received ECE flag and responded for the congestion control mechanism. Receiver will get the CWR flag and get to know that this sender has responded on ECN flag, responded on a congestion flag on behalf of the sender is seen the CWR flag. So these are the all about flag. This is all about the TCP flags. If you have any question, any query, please let us know in the comment. Thank you for watching. Please do like, comment, subscribe and share with everyone. Thank you.